Okay, assalamualaikum everyone. Alright, okay, so now we have this chapter 2 with the topic of vector algebra. Alright, so let's see for the introduction to vector algebra. Okay, let's look at the definition first. Okay, what is scalar? Okay, scalars means the quantities that have only magnitude. So we have only magnitude. This is for scalars. Alright, for example, let's say we have area, volume and speed. Okay, and secondly we have this vectors. What is vectors? So vectors is a physical quantities that have magnitude and also direction. Right, for example we have velocity, acceleration and force. Okay, so basically the scalars mean it is in the form of a number. Okay, it is a number, a constant number, for example. Okay, while for the vectors, basically it will be in a set of number. Okay, a set of number. Okay, that will be written in the form of matrix. Okay, in the form of matrix. Alright, so later on we will see their example. Alright, so we have done the definition. Now let's see what is vector. So a vector can be written in the form of a column matrix or a row matrix. Okay, for example, let's say here we have U. So U is a vector U equals to 1, 2. Okay, this one. Alright, or you can also write in the form of row matrix. Then you say that U equals to 1, 2. This one. Okay, so for B, so this is a matrix 3 by 1, sorry. So this is 2 by 1. This is 3 by 1. Okay, and it also can be written as V, so equals to 1, 2, 3 here. Okay, in the form of row matrix. Alright. Okay, next. The entries of the vector is called the components. So for each entry here, okay, we call it as the component of the vector. Okay, component of the vector. Alright. So basically this component, okay, the number of components, it represents the size of the matrix. Meaning, if you have 2 components, then it is 2 by 1. Okay, so the set of all n vectors is denoted by Rn. Okay, so meaning here for U, it is in the form of R2. Okay, it is the element of R2, while for V, it is element for R3. Okay, so basically your R2, it is called as the 2-dimensional spaces, and your R3 is 3-dimension. Okay, let's continue with the vector notation. Okay, if we interpret the vector geometrically, okay, we can write like this one. So let's say we have a point to another point. Let's say the first point is E, the second point is B. Okay, this line segments, it represents the vector, okay, that is from point E to point B. So this point A, okay, the first point A, we call it as the initial point. Okay, while the point B, we call it as the terminal point. Okay. Alright. Okay, basically we will write the notation for the vectors in the bold letter. For example, the notation that we use is in the form of bold letter. Okay, we can write as the bold letter, this one. So let's say we name it as vector U. Okay, or we can also write as U with the arrow above them. Alright, or we can write as in the form of the point, that is, you can write as AB, this one. Okay, that is the vector from E to point B. Alright, and this one is the notation for the vector. Okay, and we also have the magnitude. Okay, the magnitude of the vector, we use the notation is modulus. For example, we have magnitude of U, or it can be written as magnitude of AB. Okay. Okay, next let's see what is equal vector. Alright. So what is equal vector? Equal vector, we have here two vectors A and B are said to be equal if they have the same magnitude and same direction. Okay, for example, let's say we have a vector A here, okay, and you have a vector B here. Okay, so since this vector A and vector B have the same magnitude, okay, same magnitude and same direction, okay, so we say that, okay, so we say that vector A and vector B are equals. So vector A equals to vector B. Alright, okay, next, negative vector. Okay, a vector having same magnitude, okay, but with opposite direction of A, then we denote it as negative of A. Right? For example, let's say we have a vector A here. Sorry. Okay, so this is vector A. Okay, and we have another vector with the same magnitude but with the opposite direction. Okay, so look at the arrow. So the arrow shows the direction. So we say that it is negative of A. Alright, so remember the negative sign, it shows the direction. Okay, alright, next we have a zero vector. Okay, zero vector means the vector with a zero magnitude, okay, and the direction is undefined. So we say that the vector is static, okay, meaning it is static, okay, with a zero magnitude and with the direction which is undefined. Alright, okay, next we have vector addition. Okay, for vector addition, we have two laws that we can use. That is the first one, triangular law, and the second one is parallelogram law. Okay, so for the triangular law, let's say we have two vectors A and B. For example, this is vectors A, okay, and we have another one here is vector B. Okay, alright, so to add vector A and vector B, we will place the initial point of B on the terminal point of A. Okay, meaning here it will be this one. Okay, okay, this is A. Okay, we will place the initial point of B on the terminal point of A. Okay, sorry. So this one, this is B. Okay, so your new vector here, we name it as C. Okay, C will be equals to vector A plus with vector B. Okay, so this is the triangular law. Okay, now for the parallelogram law. Okay, so let's say we have two vectors. The first one, this is vector A, and this one is vector B. Okay, so for parallelogram law, okay, we will put the common initial point. Okay, here we have here is A, and this one is B. Okay, so if you can see here, it is with a common or with the same initial point. Alright, so where is your C? Okay, so the addition of vector A and B, it will be the diagonal. Alright, it will be in here. So this will be your C. Okay, so this is what we call as the parallelogram law. Alright, so your C will be A, vector A plus with vector B. Okay, now let's look at vector subtraction. Okay, alright, so if we want to find the difference between two vectors A and B, okay, so let's say we want to find C is A plus with negative B. So we can write as the difference is A minus B. Okay, for example, let's say we have two vectors here, A and B. Okay, so your vector subtraction, it will be this one. So vector A and plus with the negative of B, meaning you will get with the opposite direction. Okay, so your A minus B will be here. So this one will be your A minus B. Okay, that is, you will use, for example, this one we use the parallelogram law. Okay, alright, next we have multiplication of vector by scalar. Okay, let's see, we have a matrix A here, sorry, a vector A here. Okay, and then we have another vector here, half of the A. Okay, so we say that this new vector is 1 over 2A. Okay, if we have, let's say, 2 times the vector of A, so we say that it is 2A. So the multiplication of vector by scalar, we write in the form of KA. KA. Okay, and the magnitude will be, okay, the magnitude will be, if you have the magnitude of KA, okay, it will be equals to K times with the magnitude of A. Okay, now let's look at the laws of vector algebra. Okay, so we have here, if A, B, C are vectors and P, Q are scalars, then we have the following laws. Okay, so look at here, mostly the law is similar to the law of the matrix. Okay, the first one, if you have A plus B, vector A plus vector B will be equals to B, vector B plus vector A. And then second one, vector A plus vector B plus vector C, then you can also solve first for vector A and B and then plus with vector C. Okay, number 3, P times Q times with the vector A just equals to the Q times P times vector A. Okay, since your P and Q are numbers or scalars, right? So number 4, P plus Q times A, it will be PA plus QA. So you just expand as usual. Or if you have P times A plus B, you will expand as PA plus BB. Okay, so you just expand as usual. Alright, and number 5, we have magnitude the vector A plus with the 0 vector or null vector. Okay, then we say that it is equals to vector A itself. Alright, and lastly, if your vector A plus with the negative of vector A, then we will get the null vector. Okay, next we have parallel vectors. Okay, so let's say here we have two vector A and B. Okay, let's say this is your vector A, okay, and this is your vector B. Alright, so in this case, since your B is half of A, or since your A is 2 times of your B, then we can write as A equals to 2B, right? Okay, so meaning here, we say that vector A and vector B are parallel, because we can write in the form of A equals to KB. Okay, so the condition will be with the same direction. Okay, alright. Okay, next we have a vector component. Okay, what is vector component? Okay, a vector C containing another vectors A and B, and it can be expressed in terms of A and B. Okay, look at here, we have C equals to PA plus QB. Okay, then we say that PA plus QB are the component vector of C. Alright, so PA and QB are the component vector of C. Alright, so later on we will see what is the component vector in 2-dimensional space and 3-dimensional space. Okay, thank you.